Kepler's first law states that the orbit of every planet is an ellipse, with the Sun at one of the two foci. This law was derived purely mathematically on the basis of the gravitational force between the Sun and the planets. According to the fundamental principles of physics, the gravitational force between the Sun and the planets can only lead to a collision between them. This is the reality that even the most ingenious mathematical formula cannot avoid. Scientists describe the motion of objects solely within the framework of Newtonian mechanics. However, Newton's laws were derived under idealized conditions, namely under the assumption that no external forces exist. In reality, when a planet is in the gravitational field of the Sun, its motion is influenced by this gravitational field. On the other hand, every moving object has an inertial force. Its function is to resist the effects of external forces. This, in turn, influences the motion. The planet is driven in the tangential direction by the force of the Sun's rotating gravitational field. The magnitude of this driving force corresponds to the gravitational force, acceleration, exerted on the planet. However, under the effect of inertial force, the speed of an accelerated object is restricted, limiting its speed to a maximum value. Under the acceleration of the gravitational field g of the Sun, the orbital speed that a planet can reach is as follows. This is the orbital velocity at which the centrifugal force generated by the planet exactly equals the gravitational force of the Sun. According to this principle, the orbit of a planet around the Sun is circular if no other external forces are acting on it. When a planet is subjected to disturbance, it deviates from its circular orbit. Under the influence of the Sun's gravitational pull and the planet's inertial force, the planet oscillates back and forth along its circular orbit. In other words, the planetary orbit is created by a back and forth motion around its basic orbit, a circular orbit. It is clearly not elliptical.